All right. So, hello everyone. Welcome at my talk about designing and building a stealth C2 LDAP channel. My name is Rindert Kramer. I'm from Holland, the Netherlands, Netherworld. I'm a hacker at Fox IT. And I love extreme metal, Active Directory meets regular expressions. And that's it for the introduction. I have too much information to share with you guys, and I haven't got enough time. So if you're interested about prior work, stuff like that, hit me up for a cup of coffee or beer, and I'll bring you up to speed. So about this presentation, how did I end up with a backdoor that works over LDAP, and how do we build something like that? And a little bit information about helping the blue team. So, a little bit of background story. Me and a colleague were at a client that had multiple networks that were physically segmented from each other. And all the networks were completely isolated from each other, except from one major overlapping component, which was Active Directory. And this is how that looked like. So, network segment A, that you can see right over there, was able to connect to the internet, while network segment B could not connect to the internet and was completely firewalled and was only able to reach the domain. And that domain was shared between other networks as well. And we had physical access on workstations in both network segments, but we wanted to control the workstations remotely. So we thought it would be really nice if we were able to route data from network A over Active Directory, over LDAP, to network segment B. So that's what we did, and we started off small by building a really simple LDAP channel. And every user account has by default read and write permissions to modify some of their attributes. For example, you can modify public information such as your telephone number, your street address, your office, whatever. And many other public information attributes, basically. And these attributes needs to be accessible, needs to be readable for every other user account in the same domain or other domains. Otherwise, how would Alice find Bob's new telephone number? And since every account can write information to its account, that's accessible by also other accounts, it means that basically we can use Active Directory as a data proxy. I like high-level overviews, so another one. And let's say that we use the same user account in network segment A, and we use the same user account also in network segment B. So from network segment A, we write ipconfig into the info attribute of the user account. And from network segment B, we read the ipconfig also from the info attribute, and we execute the command. And we process the data. That's basically how that works. So a little demo. So on the left, which you can also see in the top, is Alice, which will issue a command over LDAP, which will be executed on Bob's workstation, which is on the right. Okay, so now we know that that works. So, any questions? Nah, just kidding. No, we're not done. Not quite yet. People already built some proof of concepts doing the exact same thing. There's a blog tip. Go read it after this talk, obviously. But Harmjoy from SpectreOps wrote a really nice blog post about this technique. Really cool. Go check it out. But it also depends, there were quite some issues, and, well, it depends on the replication between domain controllers. So, for example, if you write the message, the payload, to domain controller A, but you read the message from domain controller B, you might have to wait for the replication in order to get the data, basically. And the info attribute that we used in the demo can only store around 1 kilobyte of data. But if you want to send larger messages than just 1 kilobyte, which is often the case, you need more space, or you need to fragment the messages. And the accounts were pre-configured, which wasn't not really idle as well. So that's why I decided to build a more advanced LDAP channel that mitigates most of these issues. So a small spoiler for the end of the presentation, but I wrote a tool that's able to auto-discover a client and server. fragment the messages based on the attribute length that's selected, and exchange information such as accounts, attributes, CRC checksums, proxy data, and more. But there are no solutions without having a problem first, and there were quite some hurdles that needed to be overcome during the development of that tool. And in the last demo, we used the info attribute. But what if the info attribute already contains data? Are we going to override it with gibberish, crap data, for example? So choosing a different attribute is the solution for that. But how do we choose an attribute and which one? And I also wanted it to be as stealth as possible. So the new attribute has been selected, for example, but I did not want to communicate the name of the attribute directly over the network via LDAP. So I wanted to share the name of the attribute basically without sharing the name of the attribute. So chicken egg problem, catch you only two. But how do you do that? Another issue, replication. So chances are that the transfer rate of the LDAP channel is higher than the replication occurs between domain controllers. How do you fix that? And how do we communicate the chosen attribute? I mean, we need an attribute in the first place to communicate over Active Directory. So if there's no attribute, we cannot communicate. And how do we know if and when a message has been received correctly and if the integrity is maintained and stuff like that? And what if the message or the payload size is bigger than the maximum attribute space? And the last one, the whole LDAP channel depends on working user accounts. And I didn't want to configure user accounts statically. So how do both client and server, Alice and Bob basically, find each other independently? So the first step that I took was to query every user attribute from the AD schema, as well as all the domain controllers. And I stored this information into 2 separate hash tables. So as for how to choose the right attribute that we're going to use for proxy and data between Alice and Bob, I created a small process to select a suitable attribute that we can work with, basically. So we query all the user attributes, and we check for each attribute if it contains data, if the user has write permission to it, if the user can actually clear the attribute. And if that all checks out positively, we add the attribute to an array. And for now, because of bandwidth and speed reasons, the attribute with the maximum length is selected for storing data between Alice and Bob. And for data not ending up in the GUI, I could not find a really reliable way to identify attributes, identify those attributes. So I created a blacklist in code that contains attributes like the telephone number, the street address, and stuff like that that ends up in the address book. That was the most sufficient solution that I could think of. But how do we share this attribute without sharing the name? So let me take a sip of water. So we just selected one attribute that we will be using for sharing data between Alice and Bob, between 2 network segments. But since Alice and Bob, client and server, queried all the attributes from the schema and stored it into a hash table, we can simply send the hash from the chosen attribute and send it over LDAP from Alice to Bob. And both sides can basically use the hash to resolve the actual attribute name based on the hash. So you just send the hash over LDAP from the one and to the other. You can resolve the attribute name based on the hash. So how do we avoid replication issues? All domain controllers will also query it during startup and stored into a hash table. And I didn't want to send the fully qualified domain name of the domain controller that we're going to use over the line as well. So also the hash of the chosen domain controller is shared between Alice and Bob. So we have a suitable attribute. We know what to share of that attribute. We know how to avoid replication issues, but we still need an attribute in the first place to communicate. And I couldn't think of a reliable way for sharing data initially, other than having some static placeholders. So luckily there are some really old attributes that are part of the AD schema since a very long time. And I chose these 3, mainly because I think they aren't used that often anymore. And one of these 3 is chosen randomly, and the initial data that's used for auto-discover basically is written to one of these attributes. So how do we know if a message has been received correctly? So I chose to implement CRC for this whole protocol basically. So besides the data attribute that's used to transfer data between Alice and Bob, I chose another attribute that is another attribute is selected that will contain the CRC checksums. And the attribute is selected in the exact same way as the data attribute. So, nice flow. So in order to send a message from Alice to Bob, Alice would first calculate the CRC of the message herself before she sends it over LDAP to Bob. And after she sends to Bob, she will monitor Bob's CRC attribute to see if it contains data. And if it contains data, Alice will verify if the data that's in the attribute, if it matches the CRC that she calculated herself. If that's a match, then the message has been sent and received correctly. If it's not a match, she will increase a count basically, and she will wait up until 1 second in 100 milliseconds intervals to wait for Bob to receive the message correctly, basically. So the process on the receiving end is much simpler. So after a new message has been received, the CRC is calculated and written to the CRC attribute, after which the message will be processed by the receiving end. So what about fragmentation? So every message that's written to the data attribute contains information such as message IDs, the number of parts it contains of the data itself. And it's base 64 encoded, which also increases some overhead, or adds some overhead. But let's say that the attribute space has room for 1 kilobyte. So to fragment a message of 1.5 kilobyte, the message will be split in 2 parts and sent separately. So one part will be 1 kilobyte, and the other part will be half kilobyte, and it's keep track of and stuff like that. So after all fragments have been received, the fragments are reverted back into the original state. And yeah, by using this method, basically, you can send pretty large files over the network with LDAP, and it's a pretty reliable way, basically. But yeah, so we know which attributes are used in the process. Which domain controller is used, CRC, stuff like that. But how do client and server independently find each other? And a 24-byte string is built with the information of the hash of the data attribute, the hash of the CRC attribute, and the hash of the domain controller. And that hash is written to one of the static placeholders or attributes that we defined earlier. And the tool will basically query the whole Active Directory domain for user accounts the tool will basically query the whole domain for these attributes that are present on user accounts. And if they contain data and it's parsed, and if parsed successfully, both client and server basically have identified each other. But also know which domain controller should be used within the process, which attributes for data and which attribute for CRC. So now we have everything in place to create an interactive channel over LDAP. And I wanted to weaponize it with Cobalt Strike. So Cobalt Strike has an experimental interface that allows you to create your own transport channel. So that's what I did. And next. So in order to get Cobalt Strike working over LDAP, I added 2 more properties. The hash of the architecture, which is resolved basically on the same way as the other hashes of the attributes, and a randomized pipe name. And Cobalt Strike works basically, 1 slide back. So the experimental interface of Cobalt Strike will create a DLL injectable payload, that if you inject it, it will start a name pipe server. And you can specify the name of the name pipe server as well, which is the pipe name there. So this information is relayed to the external interface of Cobalt Strike. And Cobalt Strike will serve a customized reflective DLL. And this DLL is injected into a new suspended process, Notepad, which will start a new name pipe server. So I used the external C2 documentation as inspiration for that, basically. But this is basically how it works. So Alice and Bob find each other during the auto-discover. So the name of the name pipe and the architecture and stuff like that is exchanged. And Alice will forward this to the Cobalt Strike external C2 server. Cobalt Strike will return the payload to Alice. And Alice will relay or send the data back to Bob over Active Directory, over LDAP. And Bob will inject it into a new process, which will start a new name pipe server. Bob connects to the name pipe server, gets all the data that's already on the name pipe server, and forwards it back to Alice over LDAP. And Alice will write it back to the external C2 server. So at this point, a new SMB beacon will appear in Cobalt Strike. And let's say that we want to run a task, for example, take a screenshot or run ipconfig or stuff like that. The task will be sent to Alice, and Alice will relay the task over LDAP back to Bob. And Bob will write the task on the name pipe server. And the pipe server will basically process the task. We'll write the response back on the name pipe. Bob will read the name pipe, will write back on the over LDAP back to Alice. Yeah, and that's basically it. And the process will continue until the connection drops, the computer restarts, stuff like that. So, the demo, how that works. All right, so what we see here is that both Alice and Bob have exchanged their data, such as the data attribute, the CRC attribute, the name of the pipe, the architecture, stuff like that. And Alice relayed all that information back to Cobalt Strike. And Cobalt Strike served the payload back to Alice. And Alice sent the payload over LDAP to Bob, and Bob injected it into a new process, basically. So now the relaying between the name pipe and Cobalt Strike over LDAP can begin. So there's the new SMB beacon. Oh, yeah, already done. All right, so yeah, why do you want to use the C2 LDAP channel? So yeah, basically if network segments are completely firewalled and restricted and stuff like that, but still use the same Active Directory domain, this can be a pretty reliable way. Further than that, SMB WMI is often used and often monitored and blocked or restricted. And yeah, this method only requires a valid user account with no additional permissions. So even you can use this even on the workstation with a user account that's not allowed to log in on that workstation, basically. But it's still a last resort of hope. I would definitely recommend a reverse HTTPS or basically any other type of tunnel if you can. But yeah, if you cannot, then this is a cool way. So future plans, SOC support, so you can route data over a SOC server, basically. Support for multiple domains or forced, using multiple attributes for data for basically higher bandwidth. And multiple sessions on one internet breakout point. So you have multiple Bobs and one Alice, and you can just route all the data through Alice to your Cobalt Strike instance. So helping the blue team. Yeah, we're still the good guys, right? Yeah, so having a baseline is really important to detect this kind of backdoor channel traffic. So if you don't have a baseline, then you're, I think, out of luck. If you have a baseline, you can detect anomalies like many changes to an AD object. So there's the event ID. An unusual amount of traffic between clients and domain controllers. Maybe you can enable and inspect LDAP logging. And advanced threat protection from Microsoft has some specific functionality that you can monitor and trigger on suspicious LDAP queries. And that's it. Any questions? Yeah, it's a native LDAP, so secure TLS, SSL, whatever. Yeah. Yeah. So I think it's really hard to intercept traffic, and unless you're SSL offloading stuff. But I think you should be focusing on the receiving end, like logging on domain controllers and stuff like that. Yeah, you over there. Oh yeah, sorry. Yeah, I forgot that. Yeah, the tool is going to be open source. Give me 2 weeks or so to clean up the code, stuff like that. Yeah, it's going to be open source. So yeah. Yeah.
Is there anything built in LDAP to limit how often a record is changed?
How often a record is changed? Not directly. I think there are numbers that indicate that the record is changed, and you can keep track of them yourself, but no, not directly. Any more questions? Yeah?
Where can we see when you draw this? Or handle?
Yeah, so it's, you mean when the payload is executed from Cobalt Strike, yeah. So, yeah, it spawns a new process with RWX permissions in memory and stuff like that. So
I meant like when you drop the tool, when you release it.
Oh, okay. So my Twitter handle is also in the what's it called, schedule. So I will send a message on Twitter, and then you can. All right. Thanks very much.